Well, welcome everyone. We'll get started. I'm Gordon Cooper. I'm a product marketing manager at NXP based here in San Jose. I have been responsible for some of our high-end microcontrollers. We'll talk about them, but this is not really a microcontroller specific section. It's really about how you connect to the cloud. So I have with me a couple of our third parties. I have Nick Dutton and Jason Crawford from Xentry, and they have some more experience in that field. So together, I think it's a pretty good story of what you can look at to move forward with connecting your embedded product to a cloud. So let me set some expectations. It's a pretty big topic, obviously, and we're not going to be able to pick a cloud and give you all the details of how you connect any one cloud. But what we're really going to do is assume you're an embedded designer, and you maybe have already designed embedded products, and now you want to figure out, well, hey, it's a trend to connect to the cloud. I need to go do this. How do I go do this? What are the things I need to know and be worried about if I'm going to go make this happen? Maybe you're taking a doorknob and making it a wireless doorknob. And maybe you have no embedded experience. But since this is ARM TechCon, I'm going to assume that as a starting point. A little introduction that we'll go through in terms of, hey, I've got a product, but I want it to become a connected product. So that's kind of where we're starting from a conversation. And then the other piece is if you think about an embedded device, your product is no longer just the embedded device. It's bigger than that now if you're connected. You have to worry now about the user experience. Somebody's going to be on the other end of a cell phone or a PC connecting remotely. What's that experience like, and how do you interact with them that way? And then, of course, there's the cloud piece. How do they interact through the cloud? So we're really now going to call it a product as those three pieces. It's the embedded device, which you're already familiar with, or the physical device. It's the user experience, and then the cloud services. So those three things. And we'll go into each of those in more detail. And at the end, we'll very quickly talk about how do we get started from here based on what we might have available. Obviously, there's other things out there that you can go and look at. Introduction. I came across this great Harvard Business Review quote, so it's not from a vendor like ourselves, essentially saying exponentially expanding opportunities if you have a connected product. A bit of hyperbole, but certainly there's a lot of opportunity to benefit you, the manufacturer, if you're making something, and your customers by having a connected product. So let's look at a couple of examples. Let's say that you've designed a vending machine, and it's a stand-in for any embedded design that you might have. If you now have a connected vending machine, what are the benefits of a connected vending machine? Well, you can imagine that now the guy who has to stock it can just go, check on his tablet and say, oh, okay, we're out of Zagnut bars or whatever it might be, and now or can get an alert remotely rather than having to just roll the truck on a monthly basis or a weekly basis to go restock. Maintenance alerts, price changes remotely, feature upgrades. The manufacturer could actually offer upgrades remotely without actually go change the machine. So that's actually a pretty simple example to understand. You don't have to have started with an embedded product, and I always find this kind of fascinating, keyless entry. So if you have the front door of your house, if you now have a connected front door, what are the benefits? Well, you could have an alert to your phone if somebody rings the doorbell. You can take a picture of them so you can see who's actually out there, or have a little video camera so you can actually interact that way. You can create access codes. Your cousins are coming over, and you can set an access code so they can get in at a certain time that's only good for a few hours. So all these things you can do remotely. Of course, it's not mentioned here, but we'll talk about it. What's the biggest thing you worry about with a wireless front door? Security. So we'll talk about that as well. So big benefit to the user, potentially. Obviously, you have to make sure it's a useful benefit as opposed to just kind of a clever thing that's not a value to them. And a big benefit to you, the manufacturer, and again, I'm assuming if you're the developer of an embedded product, there's big benefits to you as well in terms of upgrades. Maybe you're getting some analytics back on how your parts are being used. So there's some potential benefits there as well. Yeah, you can actually feed into future product development as well. Okay, so we mentioned the three pieces. So the physical device, which I'm assuming you're pretty familiar with. Maybe you've got an ARM Cortex-M3 or 4 in there. The user experience, the connected services. So these three pieces now what we call the connected product. So physical device is one of the three elements of that. The interesting thing, obviously, is if you're good at creating your embedded product, you now have to be good at a bigger scope of things. So if you're going to have your physical device, you already know how to write Cortex-M3 code and assemble it, et cetera, and whatever else is in your device that you have to go do. But now you have to worry about including cloud APIs. Now you have more security to worry about. You're connecting, whether it be Wi-Fi or cellular or some connectivity, now you've got stacks to worry about. So all of this is in addition to what you were already doing with your non-embedded product. Then with the user experience, so there's a mobile phone or a tablet or a PC somewhere, and what version of the iOS is it? Or, oh, Android just updated the Android code. So how do you keep track of that, and what do you have to worry about there? And then, of course, with the cloud, you have to worry about managing your devices remotely from the cloud, so a device management service, and then you have to figure out what cloud to pick and the values of some of those features. So we're going to go into sections in all three of these into more detail, but which is kind of the scope of embedded device, connected embedded device. Here's what you have to worry about. It's simplistic to say in the doorknob example that you create an embedded doorknob and you sell it to a person who installs it in their house, and that one person on their cell phone interacts through one cloud service to their phone. It's not always as simple as that, right? So there might be many people. So in the doorknob experience, it might be one user. But in the vending machine, it might be a whole host of users. The guy who stocks, the maintenance guy, the shop owner who wants to know how the sales are going. So there might be multiple users involved. And with multiple users, you might also have multiple clouds. So actually, cloud is one of the hardest things to pin down. We talk about the cloud. We kind of refer to the internet. But a cloud is a specific cloud service that you can get from a company. And there are multiple services out there. And we'll talk a little bit more about what those are and what you should be paying attention to. Now, obviously, your embedded device has to talk to some of those clouds, and we'll get into those details. And of course, every connection has to be secure. Physical device has to be secure. The connection, once you open that door to the internet, open that door to connectivity, somebody can walk through it, try to steal your IP, steal your data, worse, steal your customer's data. No one wants to be the headline like a Target or whatever. Nobody wants to be the company in that headline. So how do you worry about those things, and what do you do about them? Okay, so let's talk about the physical device, which again, I'm assuming you already have a leg up in terms of using your Cortex-M processor. So here's your processor. That's an obvious one, and you're running your application code. So your vending machine code or whatever it might be that you've already written and you're already working with. Now with connectivity, you have to add a radio. You could connect through the Ethernet, IoT. People think of it as wireless. It could be wired as well. But let's assume for the sake of this argument that it's going to be Wi-Fi. It could be cellular. Bluetooth and Zigbee are a little bit more local. So if you're connecting out on the Ethernet or internet, we'll say Wi-Fi as an example. So with that comes the stack. Now you have a couple choices of where you can add the Wi-Fi, and we'll talk about that in more detail. And then you have security. Now security could be embedded in your connectivity chips. It could be embedded in your microcontroller, or it could be an external chip. And we'll talk about some options that you have there. Kind of depends. There's different levels of security. It's not really a digital function of I'm secure or not secure. Right? You can spend a lot of money in chips to secure something. It kind of depends on how big the impact of not securing it would be. If you don't want to be target and have those in the headlines, that's a concern. If you have a thermostat on your wall and somebody would have to break in and physically take it apart and x-ray it to extract the key, well, you probably have bigger problems if they've in your house to go do that. So, right? So there's different levels of security depending on what you're doing and your application is. Okay, and on top of all that, you still have to connect to the cloud. So you have the security and the connectivity, but on top of that, on top of the interface, now you have, I mentioned web servers maybe, or mobile APIs, cloud services, et cetera. So these are all software that you'd have to add. So could be one module you buy that has all this. Could be individual chips, several different choices. This probably won't come as much of a surprise for those of you who've been looking at Wi-Fi and adding Wi-Fi already. But the simplest way to go do it is, I'm assuming you have an application processor running your application. You can add a wireless module, a Wi-Fi module, for example, that has an embedded MCU in it, and that MCU will run the stack, will run the connectivity stack, or in this case, the Wi-Fi stack. And it's all buttoned up, and there's a layer of security in there. Now, that security, there's different. Sometimes that security just gets you to the cloud and back. Sometimes it just gets you to the access point. So there's different levels of security. This is the easiest, but it's also the most expensive. So if you can make 1,000 pieces of something and it costs you a couple dollars more, who cares? It's a couple $1,000s. If you make 1 million of them, okay, now a dollar or two more is going to make a big difference. So another way to go is you can actually embed it. So you can buy the module with the MCU built in, and sometimes they actually let you embed your code inside. By the way, so NXP, from a microcontroller point of view, we make microcontrollers. We sell microcontrollers into people who make these modules. We don't actually sell those modules, but all of these are valid options. I'm not, by the way, saying one is better than the other. It all depends on your application and your need. Oh, here. So the Wi-Fi module built in MCU. So this one, you actually take some of the bandwidth and memory of the MCU built into the Wi-Fi module and take advantage of that. That's obviously a cheaper solution. Maybe a great choice for you, depending on how much you need in terms of the MCU, how much I/O you need, how much horsepower you need, how easy it is to do the integration. So it's a little bit harder because now you have to integrate and work development tools. So another way to go is actually buy a radio-only module. So you can buy a radio-only module, and then you have your choice of MCUs, but you run the network stack outside. And obviously, the network stack has to be ported to that MCU. The beauty of ARM is if it's a Cortex M4, it's pretty easy to take advantage of things that have been designed for the M4. You have to worry a little bit about the peripherals. An example would be here, Broadcom has Wicked. You've heard of Broadcom's Wicked. So Wicked has been ported to several different processors, the LPC 1700, 1800, and 4300 from NXP. So you could actually take the Broadcom Wicked stack, apply it here, combine it with your application, get a radio-only chip, Murata, for example, and off you go. Now, the last one that's worth mentioning, I've seen it in very high volume customers. It's called a chip down, where you don't have a module at all. Essentially, you don't pay for the overhead of the module. You just take and put all the components down. When that gets a little trickier, one, you want to be in high volume, because now you have to worry about certifying your Wi-Fi. Now you have to worry about antenna design. So now you have to worry about things that you don't have to worry about up here. You let somebody else worry about them. That their job is to go off and get good at Wi-Fi. More flexibility, lower cost. Really the most flexibility, because you can pick any MCU, pick any antenna configuration, but it's going to take a lot more work to go get that done. So those are your choices in terms of adding your connectivity module, if you will. For the sake of discussion, we're going to pick this one. It gives you the most flexibility, an external module. None are better or worse. Depends on your application. But just in terms of illustrating a few points, we'll look at the third one here. All right, so that was the hardware. So now the software running on the hardware, you know how to write your application here. This first one is if you're going to do the design from the grounds up. You can go get that Wicked stack that we mentioned. So if Broadcom has ported Wicked to the MCU you've chosen, you've got that already. But now you've got to add all these things. You still have to figure out the cloud connectivity, how you're going to do over-the-air updates. There is some security in the Wicked stack, but there's more you have to worry about up here. So you can do all this, and people do all that. It takes more time, and there's a little bit more risk, but that is certainly an option. Something else you could do is the second option here. You can go to a cloud provider. ThingWorx is an example, or there's a bunch of them out there. You can actually go and say, all right, I want to use your cloud, and they will give you an agent to run on your MCU. So they'll give you a bit of code that connects just to their cloud. So it's a good way to get up and started. It's a little bit less flexible if you want to add multiple clouds that we talked about, or you have to go through their cloud to go do that. But it kind of simplifies your life a little bit. You don't have to worry about some of the things that they'll take care of some of the security and some of the connectivity to the cloud. You still have some things to worry about up here, though. So there's a third option, and the third option is to actually choose a company that's done an OS that has everything integrated. Now, Mbed, except for the connectivity piece, you'd still need, say, Wicked plus Mbed would be an example of that solution, where Mbed is actually trying to combine everything together and offer it for free as a tool chain with their CryptoBox, which is essentially a bunch of cryptographic algorithms. Another option is Xentry, who we have here today, and we'll talk a little bit more about the details. They've actually combined everything into a Xentry OS. So it's really not just an OS, it's an OS plus connectivity stack plus a bunch of stuff that we'll go into more detail. And that runs on multiple processors, but NXP processors as well. So some software choices there. Security. I could spend the whole topic talking about security, and NXP, I have to say, takes security pretty seriously. We have done a lot of work with passports and banking and very high-level security. Now, you don't always need banking-grade security for your connected widget. I might argue that the front door might be a good one to have pretty high security on, but it depends what you're adding. So in our simplest case, here's the three pieces of your connected product. So how do you know, however, that this person who sends a signal to her doorknob to open her cousins in is actually the right person? How do you know that somebody hasn't kind of gotten in the middle of the signal here or stole the data or cloned the device and inserted themselves in here? So all of this is what you have to protect. So I'm oversimplifying this, but essentially you're worrying about the data integrity, the data that you're transmitting back and forth. And there's some things to help you with that. So you have to establish trust with the outside world. Your device here has to go out and establish trust. Usually use authentication for that. RSA and ECC are two common algorithms you would use to do that. Now you've established trust, you need to transmit data. Now typically you can use AES encryption, AES 128, AES 256, and that's pretty secure. It's to the point where 2 to the 128 bits options, I think I read once it took about 1 million years for somebody to crack it using today's technology. So the problem isn't AES, the problem is how secure are your keys. It's only as good as your ability to put the keys somewhere that somebody can't get them. And the analogy I always use is if you have a giant steel door, but your keys are under the mat, it's not very secure. So what you really have to worry about there is the keys. You have to worry about code integrity. Obviously, you don't want somebody to steal your code and replicate things or use it to hack into your device or actually take your code and insert some malicious code. So there's some read protection to prevent people from extracting code from the micros. You want to securely boot, and most importantly, you want to be able to find a way to update remotely and securely. So how do you do over-the-air updates of your code securely? If you have connectivity, why not take advantage of that and be able to go launch a new feature or launch a firmware update out into the field? But that only works if you can trust that somebody else isn't going to use that doorway to go insert something that you don't want in your product. And last is device integrity. I mentioned the thermostat on the wall. If you're worried about somebody going in and hacking it, it's amazing the things that people will do to try to steal your keys. They have side channel attacks where they can go and insert, and in just the noise on the side of the chip, they can go figure out the keys. Or they'll actually laser it and take the top off. Now, if you use the same key in every device you have, and somebody gets that key, it could be a problem. If the key is different and they break in and get one, and there's a lot of work for them and it's not inexpensive to go do that, then it might be worth that risk. So there's chips, and not the micros, but we have secure elements that are attached to the micro. They'll actually protect your key and have secure storage, and what we essentially say is banking-grade security. So in terms of hardware, what's available, all of those security features can be done in software or hardware. There's a combination of things. Now, depending on who you talk to, they'll say, well, software isn't secure enough. There's never been 100% proven software. And there's doing a lot of clever things in terms of scrambling things in software to make it very difficult to find. I would say there's some benefits of having some hardware accelerated features into your microcontrollers or your external chips. One is it takes less code space because you no longer have to run the AES algorithm. You just do an API call to the hardware accelerated feature. Another one is if you're storing the keys. So we have a couple parts with the S here, 18S and 43S, that have some embedded security features in them. They are not tamper protect. If somebody were to take them and laser them, and eventually they would give up their secret. So it's not that level of security, but it's going to protect you from software attacks where somebody's trying to reach in and take your keys or take your code. So I would say that level of security is against remote software attacks. If you're worried about somebody, and the thermostat on your wall is maybe not a bad example of where you'd use a part like that. If you wanted to add more security, we have these secure elements, the A7 series secure elements. So this thing has been designed that all the bits are scrambled. If somebody lasers it, there's no way they're going to get the secrets out of this thing. Now, if I'm designing a smart meter on the side of a house, and I'm worried about somebody cracking into the electric grid, I probably would definitely add one of these secure elements. It's a level of security that is optional for you, but depending on who you talk to, is it worth the price of 50 cents to $1 to add to your design for that level of confidence. So it's a choice. I didn't go into a lot of details, but essentially what the secure element provides for you is some common criteria certified authentication and some security storage for your web certificates, for your keys, et cetera. And it will work closely with the 1800 or 4300 microcontrollers, so we have examples of them working together. In fact, we have an evaluation board that has both on them, if you're interested. Let me hand it over to Nick from Zentri.
What we were talking about a moment ago was trying to avoid a ground-up design. Why avoid a ground-up design? The most important reason to do that is because while you're designing, you're burning money. If it takes you 3 years to get a product out, that's 3 years of burn before you start making money. Now, a competitor may be talking to customers quicker than you. So it's very important to try and maximize the tools that you've got going. So the tool that we're talking about today primarily is our operating system. It's the Xentry OS, as we call it. Xentry OS is a complete stack specifically designed for embedded devices at the edge of a network primarily. So all of the little things that you might not think about until you start getting into this product are built into Xentry OS. So for example, if you wanted to build a cloud product, you might need multiple connections. Do you need a local connection? Do you need a cloud connection? If you're talking to the thermostat while your wife or your husband wants to kind of get some information out of the thermostat, where are all these connections coming from? So managing those connections is actually quite tough. Making sure that you're servicing all those people in a time that they expect is pretty tough. At the same token, a serial interface. What if you do have that external microcontroller? How long is that microcontroller going to give you across the interface? So all of these things are quite timely choreographed so that we can support the maximum number of connections with security at the same time to ensure your product is secure. But at the same token, there's also all these other things that you might want. Servers, web servers. You want to put nice, pretty web pages together. You want them to run locally. Maybe you want them to run in the cloud. Well, if the cloud's down, if the Comcast internet connection's broken, how do you maintain that product? Right? So if your thermostat has to go via the cloud, and you have Comcast out, what are you going to do? Well, you're either going to freeze or you're going to need to start taking tops off. Right? So that's very important. And a lot of cloud providers want you to channel through their cloud. So when you do your design, you've always got to think about the flexibility of your product and how these problems affect you along the way. And, of course, your customers. So, of course, there are lots of things that we want to do with an operating system. We want to look at the A to Ds. We want to look at the GPIO. We want to do that as quickly and as simply as possible so we can get back to the task at hand, maintaining those connections, giving the results to people that want them. So all of this lot, as I've mentioned, is very tightly integrated. So really at this point, all you need to think about is your app. So if you've been making doorbells for 20 years, the marketing guy says, we need it wireless. Fantastic, we'll make it wireless. 5 minutes before you finish, he says, and I want it to send a picture from that camera. Where's all these connections coming from? You didn't design that way. The OS has everything built into it to make that simpler for you. Okay? So we speak a little bit here about the user experience being kind of the most important thing. Yeah, from an embedded standpoint, you want it to work, you want it to be robust, you don't want to have the returns and things like that. But of course, your brand's on the line here. Your customer experience has to be pleasant, right? There are many products out there that are fantastic products that fail because they didn't think about the user experience. So what we want to do is we want to return to this slide. Let's just think about these people. We mentioned this a little bit earlier. We quickly glazed over it to say there are multiple people. But those people have different reasons. We've got a shop owner. He wants to know that his revenue machine isn't broken, right? It's no good having a vending machine if it can't vend, right? So how can he want that? Well, maybe he wants text messages in his pockets. Maybe he wants to know that there's no stock in a given thing. He needs that information to make money. The other side of things, the manufacturer. Well, if you've got a vending machine and it's got 6 layers of products, but nobody ever buys from the bottom 3, why are you spending money making the bottom 3? Make the machine smaller, right? Offer different features. You can only get that really from a connected product. So a connected product could live stream good information back to the manufacturer. That manufacturer is you, right? You are arguing with your component distributor over 10 cents, 5 cents, 50 cents, but you insist on putting a button on the product that nobody uses. So this information is really good information to help you get a better product. And that's where the connectivity at the manufacturer really starts to help. Of course, there's other guys, the stock guys. He wants to know what sells best. Is it, generic brand cola or is it, lemonade? I don't know. You've got the maintenance guy. He pulls up in his truck. Does he want to get out the truck if the machine's okay? How about he just asks the machine from outside, continues on to the next guy? The end user, of course. Well, this is the most important person so far. But we just introduced 4 new people with a valid reason to get data out of your product. Now, every product's different. It may not be this many. It may be more, maybe less. But thinking a little bit out of the box in terms of connectivity and what it can give you can make a vast difference to what that product does and the user experience they expect to get. Now, there is, of course, one problem, and that is, what platform does that end guy use? Well, we all know that the guy that's wanting to buy from this vending machine is putting a bit of money in. He wants a couple of buttons, a couple of flashy lights. But the account manager, he loves his Android. He's going to use nothing but Android. Okay? Meanwhile, you've got the inventory manager. He wanted to use his Windows machine. You've got the shop owner. Yeah, the inventory guy's got a machine this big, but the shop owner likes his laptop. Right? It's a much smaller screen. Can we get that information to the people appropriately? So that sounds quite complex, actually, and once you start thinking about it. So there are actually really 2 ways to go about giving that information from the connected aspect. Of course, the money into the vending machine is always going to be the money into the vending machine. Well, that's not necessarily true. Credit card, that's a cloud service. Certain payment mechanisms, that's a cloud service. But let's look about the physical device side of things. So you've got guys that like the browser. So what's really good about a browser? Well, fundamentally, what's really good about a browser is it doesn't really change very fast, right? There may be lots of browser vendors, but fundamentally, the experience remains the same for a couple of years in a go. There are similarities, whether you're on a PC, a Mac. The new browsers are all supporting rotating phones, and so it gives you that similar experience across devices. The con of this, of course, is that if you're making a local connection versus a cloud connection, you now need to have web files in your product. The HTML, the colors, the graphics, the this, the that, the other, to provide that experience to the end user. So it does use a little bit more bandwidth, of course. It will require you to have more memory to store those files. The good news is Xentry OS has a file system in it. But fundamentally, you're sending both the graphics and the data, right? Now, the apps guys, they will tell you you've got a rich environment. Everybody's phone is fantastic. Can you imagine going back 20 years and just remembering what you had available to you then? The phone, the tablet, it's a fantastic experience. But here's the problem. Yesteryear, I was on this given phone. Now I'm changing to that phone. The screen size changed. The operating system's changed. I've got to rewrite my app. So the downside of an app-based strategy is you're always in a maintenance loop, right? That's not necessarily a bad thing, but where do you draw the line to get onto the next product, right? You've got a whole pile of information being fed to you as the manufacturer that says, they like this, they like this, they don't like this, they like this, they like this, they like this. You've got to now stop dealing with that because the phone vendors just brought out a new one, right? And that's a yearly thing. all right? So we think about that a little bit in this respect. Now, again, as a company, Xentry, we try to address a lot of this. So we do have a mobile SDK, which has a lot of libraries which take care of a lot of stuff for you. But that's one of the important things to think about generally. Okay, so a quick summary. I said Xentry OS has got a lot of this stuff in. So in the top corner, here's an example of a web page being dished up by this microcontroller across this radio that I've got in front of you. And I'll show you this if we have enough time at the end. So there is an embedded web server built into the OS. There is the read-write file management system, a secure management system. We support MDNS. So what is MDNS? Well, do you want to get your product out and go 192.168. What was the number? Or do you want to go myvendingmachine.com? All right? That one's easy. So MDNS gives you that functionality, and it's a user experience functionality. The benefit is, if you're going through your home router or going up to Comcast and coming down, if that connection breaks, MDNS will still work, right? So there's other things to think about. You're here thinking cloud. So yes, it supports REST. Yes, it supports WebSockets. It has a number of APIs supported from it. So if you like to use JavaScript, if you like to use Python, all these things are managed by the Xentry OS system as well. Of course, as I mentioned, we have the mobile SDK, which gives you the ability to do apps quicker. So here in the bottom right-hand corner is a quick screenshot of a reference app that we have. But moving on, let's talk about the topic that fundamentally you thought we were going to talk about. This is still a massive topic, okay? So we got to think about a couple of things. First off, let's get the terminology right. When we talk about a cloud, it's not the internet, right? What a cloud is, or what the cloud is, these are services that run somewhere, right? So if you've got a company that runs a cloud, great, that's the cloud. But if you suddenly want to use analytics with somebody else, there are many other clouds. So an example of this is eBay, right? There's a local company. They let you give them money. They let you take money back. They let you do a shop. That's their services. That's their cloud services. But then when the transaction happens, they pass you off to this other company, as it is now, PayPal. That's a different cloud. So clouds have to be able to work with each other. And if you create a bottleneck in your design here, your whole product may flounder at some point in the time, which is a user experience thing to think about. Okay, so let's just talk about what cloud kind of things go on. So there's a data exchange mechanism. This is, I've got to get my data from here to here, back again, send it over there. This is all data exchange kind of stuff. There's lots of companies that do data exchange. Fundamentally, they are sensing products, acting on products, sending it over there, getting it back, allowing you to control stuff. There's another part of the cloud side of things, which is the whole device management. And this is the bit everybody doesn't think about. This is the bit where your security starts coming in. You've got to be able to do firmware updates knowing that this firmware is going to that product and not to another product. Or somebody in the middle is not hijacking, and putting fraudulent software in. These are all very important things. And so device management is a key focus to any cloud. And if you're not thinking about device management, we really need to help you get there, because this is what will break a product if it's done incorrectly. The key thing, as Gordon mentioned as well, though, earlier, is security always has to remain paramount, right? APIs are available, but security is the paramount thing to think about. So let's look at these two things. Data exchange. Our vending machine again. It may sync data, it may source data. What are we talking about here? We want to change the prices, we want to report up what's working, what's not working. There are multiple cloud vendors out there that use different protocols. The MQTT, CoAP, the list is endless, of course. And those protocols depend on a vendor. So from an operating standpoint, we need to make sure that we're the most flexible solution so that really, whatever cloud analytics or command and control kind of thing you want to do, the services are available to the cloud vendors you may choose. Now, I'm not telling you we don't do cloud services, because of course we do, but we are very flexible. We do not mind what you need to do, and we, as an operating system vendor, provide that capability. Okay, so with that in mind, let's talk about the device management thing, which is the thing that I was key at letting you know about. So how can device management benefit your product? Well, of course, there's firmware management. If you make a single PCB with a single stuffing on it, but you want to sell that rebranded to them and that rebranded to them, you've got to know, you make sure you're sending the right logo to the right devices, because if this company suddenly gets their logo on their products, that's a problem. All right? So you've got to think about firmware management, and this really is a security thing. If you don't do that right, you're going to brick your devices. Right? That's a horrible thing to think about. But there are so many little loopholes in this situation that you really must talk about doing it correctly from the start. Okay, firmware distribution and license management. Well, let's say I have a product, a given phone, and I want to sell that for $100, but my executive customers would like to give me $200. Well, if I make the same thing and can remotely turn that on, the extra functionality, that's easier for you. It's a single SKU. I can remotely enable it for that customer, right? Maybe the customer does it itself. You create a website. You say, put your credit card in here. What's your device? And it enables the feature. A lot of you are doing this already with your CAD tools. When you did your layout tools, you suddenly decided, I want to buy routing, or routing for everybody that speaks English. So is this a new idea? No, really it's not. Apple's been doing it forever, right? You've all got your phones. Google's been doing it forever. You're all buying these apps. They don't let you run the apps on somebody else's phone. They are signed to your device. You paid for that. That's yours. That is not a new idea. And it is a multi-billion-dollar industry for a couple of phone vendors at this point in time. So there's lots of things to do here. Key thing, do it right. But look, this all comes through one little cloud service which is really useful to you. It's a device management service. You don't have to roll your own device manager. We have this service. You only need to touch this cloud once, and that's in your production, which enables the features you're wanting to do, loads the keys in that you're needing to load in, making an individual device unique. Now, later, you might choose to use a device management service again to enable you to do firmware updates. But if your product never needs a firmware update, it doesn't need to touch it. So, of course, we are here working with our friends at NXP, and we are facilitating a lot of these things that their customers are trying to address. Firmware updates, make sure they're secure. Digitally sign your IP to that device. What does that mean? Well, when you decide to go and make 100,000 products, you send your design files off to your contract manufacturer, you get 100,000 back. There may be 120,000 made, feeding the gray market. But if you had device management, those extra 20,000 that were made wouldn't work, right? You remain in control. The whole point of device management is you enabling your features to your customers that have paid you the right amount of stuff, right? So device management is quite key. Okay, so how do we get started? Well, of course, there's something we announced yesterday. So we've developed a plugin to LPC Espresso, which allows you to take features, all these libraries we're talking about, this device management capability, everything is there on a plugin to Espresso. And of course, we have plugins to other tools, but fundamentally, this enables this whole thing that we're explaining to you and the security it provides through the standard tools that NXP have been offering you for years. We have this plugin for your tool set that you're already using. The OS is available to you, and the DMS services are there available to you. You don't have to use everything. You don't have to use any of it. This is all a function of making your job easier.
So a great way to get started. We have some evaluation boards, as you can see in the bottom here, and you don't have to read all the blocks, but essentially it's a high-end microcontroller with a lot of features. You may not need them all, but you can start there from a development point of view. And then a shield board, which allows for some connectivity.
The browser is actually a really good environment on a mobile device. And it can be quite snappy. So what I've got here, Jason, is, if we can just change over to the other display quickly. We actually did a quick, fast demo for you, which is using the NXP board. It's based on, which micro is this one based on?
LPC 4300.
So this is the 4300. And what you can see here is the web browser on his iPad. So right, what are we doing here? Well, the microcontroller is controlling a I2C bus. There's an accelerometer on there. There's a humidity sensor on there. There's a temp sensor on there. Key point is you're looking at a web browser, right? And I am doing this live. Okay? How many people would like to tell me how many lines of code that is? It's about 160 lines of code to do everything you're seeing. All right? So that OS is going to make your job easy.